Hi everyone, welcome to Expert Talks Online. My name is Lyndsay Prewer. I'm a delivery leader at Equal Experts, and I'll be hosting this evening. Tonight is the finale of our continuous delivery series. It's going to take the form of a fishbowl discussion on the topic. But we're really excited and very grateful to our previous speakers in this series to be joining us tonight. They're going to start off as being the people on the panel, but we'll also welcome people from the audience to join the panel as well if you'd like to field some of the questions that come up. This evening will just be a fishbowl, so please start adding your questions now using the Zoom Q&A function. We'll be working through the questions based on those that are top voted. So as well as adding questions, keep having a look at what questions other people are adding and then vote up ones that you're keen to see covered. I'm going to hand over to the, so if you'd like to join the fishbowl panel once we get going and answer some questions, and use the raise hand function, and our Steve, who's working in the background, will get you added to the panel. So I'm going to hand over to the panelists now, and they're going to briefly introduce themselves and just remind you what their area of expertise is. So if we start with Lisa, over to you, Lisa.
Well, thank you. Thank you. Yeah, I just spoke last week, so it's fairly fresh in my mind. But I talked about last week was getting your whole delivery team together to talk about the level of product quality you want to build into your product and the commitment you have to doing that and succeeding with your goals, like accomplishing continuous delivery. And we need commitment like that to overcome the problems that we run into. So this is something over the years that I found really useful to do with my teams. When we did this, we were successful at becoming high-performing teams and succeeding with continuous delivery. And I encourage people to use visual models to spark and guide conversations among team members to identify risks and come up with strategies such as, how are we going to fit all the testing activities, including the human-centric or manual testing activities, in and still be able to deliver small changes frequently at a sustainable pace. How can we shorten our feedback loops? So visualizing things like our pipeline help us talk about that. And also, I like to emphasize building relationships among your people in your team, especially if you've just transformed to a Agile or DevOps culture and you're new to working outside of silos, but also outside your team, other people in the organization can help you achieve your goals. So it's really important to build those relationships, ask for help, offer help, and design small experiments with specific goals and measurements so that you can improve one little step at a time. So that's kind of my approach to successful continuous delivery, and especially making sure we keep on with quality as we do that and have confidence to do it.
Great, thanks Lisa. Dave, over to you.
So I'm an independent consultant. I'm one of the authors of the book called Continuous Delivery, which I think prompted what we're talking about to some degree this evening. Continuous delivery is kind of an extreme form of Agile practice. It's the offspring of extreme programming with a bit of science mixed in terms of approach. So I think continuous delivery is a genuine engineering discipline. In my talk, The Rationale for Continuous Delivery, I described what I meant by this in terms of using the ideas of optimizing for fast, high quality feedback so that we could become better at learning, which is kind of at the root of, to my mind, of Agile practice. And that involves all sorts of things. So I think of continuous delivery as a relatively simple thing to describe. We're trying to optimize the process from idea to working valuable software in the hands of our users and make that as efficient, repeatable and reliable as we can achieve. And that's pretty much it. The problem is that changes nearly everything about how we think about software development, and so it's very challenging to manage to be able to do that. But that's what I think that we're here talking about this evening.
Great, thanks Dave. I'll hand over to Ben, who really is the head of Agile Delivery for MDTP.
I might start denying it at some point, but yes, currently. So yes, I gave a talk and gave an overview, I guess, of how we attempt to harness the power of continuous delivery to achieve good things. I also talked about some of the challenges of doing that in a large government department, and the importance of having a really great culture to accompany it. We're still really, really busy, which means I haven't prepared for this in much the way that I hadn't prepared last time. A lot of us are on video calls 9 to 5. I've got a new theory as to why. It's previously had to consider whether it was worth traveling for any given meeting, but now they're all online. You can't really get away with that, but I think I'm going to have to start doing that. You know, would I actually drive to Telford to attend this? And if the answer is no, then I'm going to decline them, I think. We're now focused on a new government scheme, which I'm sure is very important as well. It's about providing extra support to the hospitality industry, encourage people to go out to restaurants. It's generated a few additional challenges for us, I think, mainly around huge unknowns. I don't believe the British government has ever run a restaurant finder service before, and we have absolutely no idea how many people might actually want to use this. I think a lot of us suspect that the British people love nothing more than a bargain, and so it's quite likely that we will see some large peaks of traffic. But that's me.
Great. Okay, thank you, Ben. Over to you, Stuart.
Hi everyone, I'm Stuart Gunter. So I am the security practice lead at Equal Experts, and the talk I gave a couple of weeks ago was about how we incorporate security practices into continuous delivery, particularly focused on the two sort of extreme ends of the spectrum, or the process rather, looking first at the kinds of ways that we tend to see companies adopt security requirements gathering methods, and the ways in which that starts to crumble under a much more fast-paced delivery method. So where perhaps you were investing a lot of time up front trying to identify what all these different security requirements were that you were trying to build into the system, and then trying to make sure all of those things had been met right from day one, trying to look at how you can effectively split that up using techniques like threat modeling and so on. And then also looking at the other end of the process, where typically a team that's been spending perhaps a few months building a piece of software would have a penetration test to validate that all the security requirements have been met and that there weren't any security vulnerabilities remaining in the software that could easily be discovered. And then that would be like a security assurance gate that could be a mechanism for validating that before they can go live. And then looking at how that also falls apart when you're looking at an environment where you're trying to do deployments multiple times a day, and you don't really have the ability to do that sort of manual inspection process as effectively as perhaps you would under a 6-month delivery cycle. So we looked at things like automating security testing as far as possible, particularly driving the automated tests from the outputs of your threat models that you did earlier on in the process, but then also looking at how that investment in security test automation frees up your headspace when you're in production to actually learn from production a lot more when you're free to take everything that you can inspect out of production and feed that into the beginning of the feedback loop again. So we can take advantage of things like chaos engineering or bug bounty schemes or whatever it might be that you are able to apply to production when you're no longer focused on proving compliance or trying to catch up on any of the requirements that you missed right in the beginning. And that was pretty much the focus of the talk, but I'm sure we'll get some interesting questions that'll go broader than that today.
Great, thanks, Stuart. Then lastly, myself. So I spoke some time ago on how I've seen two different organizations with very different architectures improve their continuous delivery approach. One was an organization that was in the private sector that had a couple of monolithic applications, yet they were still deploying every week with a lot of traffic hitting those applications at the same time. I also talked about microservice-based public sector organization and how they were using a microservice architecture running about 1,000 microservices and also improving the way they were doing continuous delivery. Okay, so that's a brief intro from us. So we'll move on to the fishbowl discussion now. If you've got questions, it'd be good to add them to the using the Q&A function that's there. So we can start working through some of the things that you'd like to discuss tonight. Okay, thanks, Neil. We've got one come in. We'll just, should we start off with that one to give people a bit of time to kind of bring some others up? So anyone on the panel would like to tackle that one? What are the main challenges of working remotely during lockdown while delivering continuous delivery? Anyone on the panel want to start with?
So I certainly can. I'm not sure that the main challenges are really related to continuous delivery. I think some people find working remotely really easy, and I think we're working in a sector where we certainly have the technology and the ability to work this way. The main challenges, I think, for a team are around not having the opportunity to, build those relationships. And in some ways, broader than that, some people don't have the space, the physical environment in which to work, and going to an office was, an easy way of achieving that. In terms of continuous delivery, I think we should have the technology to make that feasible. There shouldn't really be any difference.
Can I go?
Yeah, go for it, Dave.
Thanks. So just to add to that, I think that's right. I think there are some advantages to a continuous delivery approach. I have to say that I am not in a position to be working with a team in the current situation. As I'm an independent consultant, and so I'm not working with teams delivering software in this situation. I have worked with continuous delivery in quite a few environments that were distributed and where development teams were remote from one another. And so I think one of the advantages that continuous delivery and continuous integration give you is clarity in terms of where people are, whether they're sat in the same room or whether they're sat in different rooms across the planet. It gives deeper insight. I once worked on a team on a project that was not almost but not quite 24-hour development. We had different development centers spread around the planet, and we were using, this was in the early days of continuous delivery, but we were using a fairly sophisticated version of continuous integration. And it meant that when the American team woke up, they were taking on and working on the same body of code that we've been working on in London. And when we woke up, we've been working on the same body of code that the team in India was working on, and so on and so on. And so it gave us a much clearer picture of where we were at any given point. I think the kind of full-on continuous integration style that's inherent in continuous delivery gives us this much clearer and deeper insights as teams, and allows us to work more effectively in larger groups, and to kind of hand over work. If you want to hand over work to somebody, give them a failing test. That's a really nice place to start from, and ideas like that. So I think there are some good things. As Ben said, the technology is in place to allow these sorts of things, but sort of, taking it on board and applying it, fully, it can be really advantage in these sorts of situations.
Thanks, Dave. Okay, anyone else want to add? Should we move on to our next question? Let's move on to the next question. So we've got a few questions that came up at the end of Lisa's talk last week that we thought would be useful to cover today. So, sorry, Lisa, that might be putting you on the spot a little bit, but feel free for other people to contribute to these questions as well. So there's a question, and I think this question came from myself actually. I remember Lisa talking about the benefit of drawing out the pipeline that the team were working with, and doing a value stream map, I guess. And you talked about how some of the teams you worked with, it was quite hard to convince them the value of that, to actually get them to contribute to drawing it out. And I wondered if you had any experience of where teams, it was easier, or approaches that you took to make it easier for teams to draw out their pipeline.
Yeah, it's embarrassing that I go around telling people to do that because I know how powerful it is because I know other people who do it with their teams. I think one of the problems that I had is, you know, as the tester on the team, I feel like a fully valued member of the team, but nevertheless, I think it's hard. It's a little harder for me to influence mostly the people who are doing the coding and the operations, you know, more than I am. And, you know, then it's also a problem of, you know, many teams have that, oh, I'm too busy. I'm too busy drowning to learn how to swim. It's like, we don't have time for that. We don't have time for that. And that's a symptom of the team not managing their workload properly and maybe making too many promises to somebody that, yes, we'll deliver by this point. So I think that's one problem, but I know other people who are people who are consultants. So they're coming in, they're external consultants like Dave, and they come in and say, oh, here, let's go, you know, it's lunchtime. Let's go to the cafeteria and of course now you'd have to do this remotely, but let's spread out the cards and see what our pipeline looks like. It'll only take an hour. And it's a lot easier for them to get that buy-in. And I also think does the team have a habit of getting together to have these conversations? So a lot of teams aren't used to, they don't want a meeting and they're not necessarily used to getting together to do something productive together. So I think part of it is just like, oh, we could have a workshop type session where we're doing something hands-on that is productive and useful, and that kind of changes the culture. Maybe Dave has better ideas than I am, though.
I think you're right in terms of it's useful to be able to visualize work. It's just useful to be able to do that, and you get really deep insights by doing that. And I agree with you that it's kind of it's a weird thing, but people in my sorts of situation are often listened to differently to people already working in the organisation, which is stupid, but is true. I'm very grateful for that because I make a living off the back of that these days. But it's, you know, I think it's my belief that software development is one of the more difficult things that human beings undertake. I think it's a deeply, profoundly complex and interestingly complicated activity. And I think that we don't pay enough attention to that. And I must confess that it frustrates me when people say things. I'm not frustrated with Linda, but when she says, sorry, Lisa, but when she says things like teams, you know, people don't like meetings, that always drives me crazy when teams say that, because it's a collaborative exercise. Unless you're writing software alone, it's a collaborative exercise, and we need to coordinate our work and think about how to work together. The deployment pipeline for me is a really deeply important idea. It's an organizing principle that goes from commit to releasable outcome, and does everything that's necessary to achieve that releasable outcome. You don't get there by burying your head in the sand and everybody working independently of one another. You get there by working in deep collaboration and by using all of the tools at your disposal to explore the ideas. So I think that a team that's reticent about drawing these sorts of things out or visualizing these sorts of things, or even worse, getting together in a meeting to discuss these sorts of things, is a team that's not doing very well. They're a team that's not going to be at the top of their game. And so, you know, I think it's important to be able to try and help people to do better.
Yeah, and oddly, I can't, you know, this particular team, I was quite successful at getting them to do other things. It was just like certain things, I don't know if they thought they were too touchy-feely or something. Certain things I couldn't get them to do, but other things, it's like, yeah, okay. So who knows?
I have to be fair, it happens to me from time to time as well. Every now and again you're in a room and you start talking and you're aware that what you're saying is just not landing with people. It's just frustrating when it happens.
Great, thanks for those contributions, Lisa and Dave. Okay, so let's move on to our next question. So we've got 2 votes for 3 at the moment. So we'll take G. Stober's question about being in the highly regulated domain. Our software goes through a vigorous compliance check which lasts 2 to 3 weeks. How do you manage your dev cycles and dev environments during this period while continuing to develop for the next cycle? We currently only have 1 dev and 1 QA environment. Wow.
I'd like to have a go at that one, if that's okay. This is kind of my sweet spot, I suppose. I spent much of my career, certainly in the latter 15 years or so of my career, working in heavily regulated environments. The consultancy that I operate now, I tend to work for larger organisations, often in technically demanding and culturally demanding circumstances for one reason or another, and nearly always in heavily regulated environments. It's my belief in terms of principles that you can't genuinely be compliant unless you practice continuous delivery. The automation and the deployment pipeline that we just referred to is in precisely the right place to be able to tell the story of a change. If you imagine building a deployment pipeline that automates virtually all of the evaluation of a change on its route to production to the point that you get a releasable outcome when there's no more work to do before that goes into production, then you can't imagine building that kind of system that doesn't also give you complete traceability and complete visibility of failure. If a single test fails in these sorts of environments, you reject that change. Regulators love this kind of thing. And so the real answer, the real answer to getting excellence in a regulated environment, in my experience, is not to slow it down with more and more checks, but to speed it up with more and more checks. So you accelerate the process of evaluation, you automate as much as you can, you make it as efficient as you can, and you make it as deterministic as you can. And this way you get fantastic repeatability and reliability. One of the things that I did towards the end of my career as actually somebody that wrote software for a living, rather than somebody that talks about writing software for a living, was I built one of the world's highest performance financial exchanges. And it was harder for us to release a change into production that was not compliant than it was for us to release one that was compliant, because compliance was automated and we would have had to bypass the automation in order to cheat compliance in our system. And I think it is important. I now consult in healthcare, in industries, finance, telecoms, motor vehicles, all sorts of things that are heavily regulated. This stuff really, really, really works in those environments. So being in a compliant environment is not a reason not to do it, it's a reason to do it and to take it seriously.
I would just add one extra thing to Dave's comments, which I totally agree with. The piece that I think is really important to cover on is a bit of the culture aspects of this, because I think that quite often that's where these sorts of challenges really flare up the biggest. It's not enough to just automate things. You've got to bring the auditors or the people who are responsible for signing off that compliance check along for the journey. So if you invest a huge amount of effort automating all your compliance checks into your code base, but you don't do that crucial step, you will still have the 2 to 3 week vigorous compliance check that you had before. All you would have done is automated the stuff that satisfies you. But if you bring the people who are responsible for actually providing that compliance sign-off on the journey, get them to buy into the process and understand it and participate and co-own it with you, you'll get a lot more success than if they feel that it's something that's being thrust on them, particularly if they're non-technical. If they don't have an engineering background, but they understand the regulation very well, they may need your help and just trying to understand, well, how does this thing that you've built show me that you've satisfied this regulatory requirement? You might need to do some work there to just translate technology into regulation for them. And once you've tackled that, then your job will be made so much easier for all future changes.
I would agree with that 100%. I think that hits that's spot on. One of the techniques that I recommend is to treat compliance as a source of requirements. So when you're dealing with your regulators and your auditors and your compliance people, treat them as a community of users, mine them for user stories, and implement those user stories. make sure that they get what they want. They get the tools that they want, they get the visibility that they want, they get the safety that they want. Ultimately, compliance is about trying to work, nearly all regulatory regimes are about trying to ensure that we can't hurt people with the software that we create, and that when we do make a mistake, it's traceable. We can kind of find out what went wrong so that we can kind of figure out how not to do that in future. Largely, that's what regulation is about. And so, it's a laudable aim. The fact that the people doing it often are paperwork heavy and so on is an accident. That's not what their real job is. And so you can help them deliver their job more effectively, make safer software more efficiently. Unless they're very strange people, they're going to be on your side.
Why do I always meet the very strange people? I completely agree with what everybody says, but to go back to the question, I don't think you can, or it doesn't matter how you manage your dev cycles in dev environments unless you tackle the bigger problem, which is you need to find out what the vigorous compliance check is trying to achieve, and potentially build something to achieve that for them quicker than they believed possible.
Great, thanks folks, that's a good discussion. Let's move on now to Erna's question about which is better to start with when you're establishing a new group focused on continuous delivery. Is it focusing on metrics first or theory and practice first?
I can go first again if you like. I'm talking too much though. I think the real answer to this is that it's a little bit of both. I think that continuous delivery is a very, very different mindset. It's a deeply, radically different approach to the practice of software development. And so you need a little bit of helping people understand what it is, what on earth it is that you're trying to do initially. So I think that some theory, it doesn't need to be lengthy, it doesn't need to be deep, but you need a little bit. You need to have a chat with somebody before you start to say, we're going to be doing some really strange things. We're going to be working to be able to create releasable software multiple times per day, but there's some really good reasons why. And I think it's useful to get that in place. Very, very, very quickly after that, the things that I would try and get in place are measures of throughput and stability. So continuous delivery is one remarkably powerful as a tool, because you can simplify down. If you optimize to reduce your cycle time, so you need to think about measuring your cycle time, you need to be getting that down. But you optimize to reduce the cycle time, that will drive out nearly all of the good behaviors you need. If you get to the stage of being able to create a releasable outcome multiple times per day, however you're doing that, you're doing well. And so that's the kind of principle. So that's the kind of principle that you want in place. You want some understanding of why that's useful, enough to get people enthusiastic enough to try and go for that. And then you need the measurements in place so that you can make many, many small changes and see whether each small change moves you closer to where you want to be or further away from where you want to be. And stability and throughput are the best measures for that. So stability measures the quality of our output. It's based on measures of the defects rates and the time it takes to recover from those defects. Throughput measures the efficiency of our development process. It's based on measures of lead time from commit to releasable outcome and how frequently you put changes into production. Those two measures in combination tell a good story. It's not perfect. We'd also like to be able to know, is this the right idea? Is this a great idea? Am I working as efficiently as possible? But we don't know how to measure that with any kind of scientific rigor. We can measure stability and throughput, and they are proxies for important things. So start off with a little bit of theory, get those measurements in place, and then make many, many, many small changes and evaluate, does this move the dial on stability or throughput or both? Does it make it better or worse? And if it makes it worse, stop doing that change. If it makes it better, do more of that change.
Yeah, I was just gonna say, this is again where I like a visualization, and I've seen a lot of people recommend the value stream mapping approach to do the visualization, do the pipeline or the value map visually, and start seeing what's the bottleneck you should get after first, and like Dave said, take it one step at a time. You know, I'm a big fan of small experiments. Set a goal, something small and measurable, and you'll know in a week or two, is it going the way you want it to go or not? And that, I mean, the teams I've been on that achieve continuous delivery, that's how we did it. And I've seen a lot of leading practitioners, like, they recommend that. So there's a reason they recommend it, because it actually does work.
I think to put what you both said a kind of different way is, so at least where you finished, there's a really powerful model for helping people understand the need to change. That's the ladder of inference. Google it if you've not come across it before. And I think there's a different way of explaining why Dave was saying that you need both a bit of theory and you need some metrics. Because if you start with just the metrics alone, you know, people are at the bottom of a ladder, and metrics, I think, are maybe a couple of rungs up that ladder, and that ladder is going all the way up to having continuous delivery in place and kind of iterating in the improvement of it. And so if you're trying to present people with metrics that explain to them, you know, how much pain they've got and how far away their processes are from continuous delivery, all those metrics might, you know, tell a really, really compelling story. It still, I think, will be difficult for people at the very bottom of the ladder that don't have any understanding of continuous delivery to get their head around. So starting at the bottom by, you know, understanding what a team's context is and what it is that they're trying to achieve, and what their current understandings are of delivery approaches, and then starting to introduce them to small amounts of theories and principles that are just enough so that when you then bring kind of metrics in, they can look at the metrics and they'll be able to relate to them in some small way. It might take a few iterations as well to, you know, for the metrics to make more sense for them to actually understand what's the deeper meaning behind these metrics, what are they really showing. And so I think that iteration of giving people a bit of theory to help them up a rung, and then some metrics to help them up another rung, can work quite well. Okay, shall we move on to the next question, right, which is from Harry, who asks, why is inspecting and adapting often forgotten as something paramount to agility? Best practices are great starting points, but if it does not work for the team, then we move and figure out what works. So what are people's thoughts on inspecting and adapting and how they combine with best practices?
In the absence of anybody else, I'll go.
Go for it, Dave.
So my real answer is I have no idea. My favourite soundbite to describe what Agile is about is inspect and adapt. I think it's kind of front and centre in why it's valuable to me. My take on Agile is that the reason why it really works is quite deep. I believe that what we're doing is that we have a kind of informal scientific method approach to solving problems with Agile, and inspect and adapt is at the heart of that. I believe that continuous delivery kind of strengthens that a little bit and kind of puts the scientific things a little bit more prominently in the way that we talk about it and use it. We talk more about measuring things, and, you know, we're kind of hard line about the experiments that we carry out on our deployment pipelines and that kind of stuff. But I think it's really deeply important. I think that the reason why this is challenging is because scientific rationalism is a hard way of thinking about things. It requires discipline. It requires us to reject many common instincts to jump into conclusions for problems. I spent the vast majority of my career as a software developer doing nearly everything based on guesswork. It was only in the latter part of my career that I really started learning that I should be measuring things and trying things out and really consciously trying to construct experiments so that we can inspect and we can adapt to the results. And when I started doing that, the resultant performance of the software that I created and the approach to deliver it was orders of magnitude better than anything that I'd seen before. So I'm a believer. I think that applying these kinds of genuine engineering disciplines to solving problems in software is a deeply better way forwards, and is profoundly important. And I think that we've got to get out of the kind of software industry as a fashion industry kind of approach to ideas, and get more into evaluating ideas and using rational arguments and measurement and working to control the variables and all of those kind of science-y sounding sorts of ideas, and apply those to software. And inspecting and adapting is at the fundamental root of that, and should be front and center in everybody's approach to everything that we do, really. Our first question whenever faced with a problem of any kind is, how do we test that, to my mind? And that puts us in a much stronger position to be doing a much higher quality job across the board.
I like it when Dave goes first, because then I just get to agree with him, and that's easy. Why is inspecting and adapting often forgotten? I'm not sure it is forgotten. I think that it's hard, and you want to do it once, and then you've got the answer and you can move on. It's the going back and looking again and again and again that is difficult and feels really counterproductive in many ways. I think people like to know what works and then stick with it. It's like, I know that I can do this and that's the outcome and there we go. But that isn't what we're talking about. I also think it's because if you get a team which suddenly announces that it's agile, or more likely has been told that it has to work in an agile manner, then they can have a daily meeting where they all stand up and they think that's it. The really difficult bit is looking closely at what you're doing and doing continuous improvement to it. And it's the continuous part of that which I think it's really, really hard to maintain.
Yeah, just jumping back in, that reminds me of a joke that I sometimes make, is that the reason why Scrum has been the most successful agile discipline is because it's the easiest one to cheat. It's not that Scrum is bad, it's harder to cheat extreme programming. If you're not doing continuous integration and test-driven development, you're not doing extreme programming. If you're standing up and you're kind of talking about things, you don't release software at the end, you're nearly doing Scrum. You're not really, but it's hard. Scrum is also about inspecting and adapting, but nobody remembers that.
Great, thanks for those answers. Just to remind the audience, if you've got more questions, please post them in the Q&A tab and vote up other ones that are there that you'd like to see answered. When we're talking about best practices, it reminded me of a couple of things. So firstly, how I think when I first started doing my talk about continuous delivery and smoothing the path, I referred to kind of best practices, and a colleague helpfully pointed out that somebody's best practices may not be best for people in another context, and that was a useful piece of feedback to make me realize that they're just practices that some people find useful at some stages of the journey, and they may not be appropriate for other people's. Another kind of, I guess, common misconception about improving a continuous delivery approach is you just need to be more DevOps, or because Stuart's here, more DevSecOps. And that's also a common kind of misconception, what that even means.
Continuous delivery.
Yes,
yeah,
right.
I like to say leading practices. Everybody says best practices, but like you say, there's no best practice that's best for everybody.
Yeah.
I think it has to be leading practices, but people are always looking for this, especially managers. No offense to any managers that are watching, especially people just want that silver bullet. When we find that one thing, it's all going to click and we're going to go, just like you said, Lyndsay. And it doesn't exist, pretty much.
So I nearly 100% agree with that, which is pretty good for me. so the degree to which I think there's a special case of things that are kind of, you know, in a different league, and for me these are the ideas of science. These are ideas like inspecting and adapting, carrying out experiments, controlling the variables, measuring things. Those are not, to my mind, those are not really up for debate. I think that one of the mistakes that we made in our industry is not really treating it for what it is. And what it is always an exercise in deep learning and exploration. And so we should become world-class experts at the techniques of learning and exploration. And if we were to do that, those techniques are the techniques of science. That's how you learn things. That's how you explore in territories that you don't know. So I agree 100% about the unpleasant phrasing of best practices and that they're not always applicable. I think though inspecting and adapting is one of those things that is always applicable. I know that Lisa would agree with me on that.
Right, great. Thanks for that discussion. So let's move on to quite a specific question from David Reese. What's state of art with remote pair programming these days? Do people bother? And if so, what tools are best? Anyone want to field that first?
I can go again. I've done quite a lot of remote pair programming. To be honest, doesn't require anything very sophisticated. You can do it with relatively simple tools. You can share screens very easily these days, and that kind of thing. It's not rocket science. It's nice if you can have some kind of video conferencing. The best experience I've had with remote pair programming, I worked in a fairly wealthy trading organization, and we had very large screens at the end of our desks. So I was pair programming with somebody in Chicago. I was in London, they were in Chicago. I had a screen and it looked as though we were sitting next to each other. That was nice. That made it easier, but it's a bit expensive. So state of the art is probably that in terms of what I've seen. I don't think you need anything very sophisticated in terms of screen sharing tools or anything unusual. I don't, you know, I think that's relatively straightforward. You can just kind of remote console into you know, one system or another.
I think in terms it's more, I mean, the technology is important. I think it's more important when you're in an office together because you've got to have the space and the 2 monitors and the 2 keyboards, etc. But I think for me, the state of the art, or at least my preference, is strong style pair programming. So there are a lot of different styles of pair programming, and I like strong style because it's just great for learning and for observing. So as a tester, especially, if somebody else is driving and I'm telling them what to do, I'm free to look at the scenery. It's like if you're not driving the car, you can look at the scenery. So I'm free to observe and notice things. If I'm pairing with a programmer and I'm not the world's best coder, they can tell me exactly what to type when I'm driving. And when they're driving, I can say, I could just tell them in pseudocode. I don't have to be able to do the syntax. So it frees up more sharing. You can have a designer pairing with a programmer or a customer support person or whatever. I think cross-discipline pairing, I think, is really valuable. I've seen it be really valuable. So just in terms of learning, plus it keeps you more interested than, you know, because sometimes you pair with somebody, but they just type and drive and do their own thing, and you're just watching. That's not very helpful. And of course, the strong style pairing also lets you do what I like to call now mob or ensemble rather than mob programming, because ensemble is a kinder term. So that's all you're doing is ramping up the strong style pairing with more people and more good ideas.
Can you say a bit more about the strong style? I hadn't come across that term before.
Oh, so the way it works is you have a driver and a navigator. So the navigator decides what to do and tells the driver what to type or what to click on or whatever. So all the ideas have to go through somebody else's hand. But you switch every couple of minutes. I would say 2 to 4 minutes ideally, so you stay interested. And you can use a mob timer or something for that. Unless you get really engaged in something, I guess you can stick with it. But you switch, and so it's just a really great way to learn, because you can, as long as you have one person that knows what they're doing, then you can have really effective pairing that way. Whereas your ping pong type programming, where you're just, oh, somebody writes the test and the other person writes the code and then you switch if you're doing TDD. I mean, that's good too, but I think then people have to both be competent at what they're doing. And also because I like the ensemble approach of having people in different disciplines in the room. You have zero question queue time because the designer's there, the product person's there, whatever. It's more efficient. You get a lot more done. It's counterintuitive.
Great, thanks for that explanation. Okay, let's move on to the next question, which is from Mark Miller about how new technologies like serverless, they're giving us higher levels of abstraction, which is removing some current challenges and adding new ones. So where do we think the future of continuous delivery is going? Perhaps particularly what serverless might mean for it?
I can go again. I was trying to give somebody else a chance. So I don't think it changes the principles of continuous delivery at all. So we're trying to reduce the feedback cycle in continuous delivery. We're trying to reliably and repeatably be able to create multiple times per day something that we can deploy into production. So that's true whatever the nature of the technology. So with serverless, that can make sense. One of the key organizing principles when you start to think about this deeply and apply it in complex environments is what represents a deployable unit of software. That's one of the tools that you can use to optimize the process. So if you can make it, the deployable unit of software independently deployable, simple and small like a service or a serverless function or something like that, then cool, that's nice. But that takes more architecture. So if you change that, if you wrote your serverless function and you changed it, could you safely deploy it into production without testing it with anything else? If you can, then fine, it's easy to test, it's really simple, it's really isolated. If you can't, then you're still in a continuous delivery, well, even for the function, you still want to be doing continuous delivery, it's just easier to do. So I think it works on a variety of different granularities. The key idea here is to optimize so that we can learn effectively and carry out experiments. And we can do that really, really fast and efficiently, as we were talking about before. So serverless is good because it allows us some degree of isolation. You can use the patterns, patterns for serverless development to some degree to architecturally isolate those components. That gives you a better chance of them being more independently deployable and more loosely coupled with respect to the rest of the system. But that's not a given. You still have to think about the design of that and all that kind of thing carefully to be able to achieve that. So I think it helps. I think that serverless, as a sidebar, I think that serverless has a way to go. I think there's some interesting stuff coming. There's a bunch of people now, and a bunch of versions now of a thing called stateful serverless, which is kind of a different kind of programming model. And I think there's probably ultimately more legs in that than the stateless kind of function as a service thing that we have right now, because the function as a service thing is coupled to state is the problem. And the way you have to architect that and manage that sort of thing. So I think there are some interesting moves there, and I think it's a useful technology, but I don't actually think it changes the intent. It might change the technology. I think there's quite a lot to do in terms of improving the technology around continuous delivery and the tooling and the feed to give us those high levels of high quality feedback. But I don't think it changes the principles in any way.
Yeah, to add to what Dave's saying, my experience of teams that have been working with service technologies is, firstly, I think it requires even more discipline around using source control and approaches like infrastructure as code to ensure that what you're deploying to each environment is under source control and repeatable. it's very easy when you need to just create a raw database or put a Lambda together just to go into the web console for that particular cloud environment and do it there. That's just as bad as going onto remoting onto a web server and putting together some HTML and some JavaScript on the web server and hoping it stays there. The second aspect is the need for really good observability. That often when you're working with serverless systems, being able to understand what's happening can be a bit more challenging than with a kind of a regular stack. So you need to think a bit harder about how are you going to join up all of the different events that flow through a serverless system to be able to make sense of a transaction or a user journey, particularly when there's either a defect or a production incident. So it's important to pay attention to that. I think serverless is going to have quite a significant change on our industry, though. And for that reason, I'm kind of reskilling to get kind of more serverless skills myself, because my engineering kind of background is more in the days of doing desktop or web-based development. So I think it's important to understand the kind of technologies and how it's impacting the way teams work quite deeply. Anyone want to add to that before we move on to the next question? Okay, right. So Shamila has a question about feature flagging. How do feature flagging or canary releases work in highly regulated domains, or are those not available tools in that context?
I'll make a start on that one. I think picking up on one of the comments that Dave made earlier about this, with continuous delivery being the environment where you stand a much greater chance of being able to meet regulatory requirements, or at least demonstrate it. I think that plays into this question very well. I don't see any reason why you can't use those sorts of tools if you are demonstrating compliance automatically as part of your release process. I would say, though, I'm personally a little bit cautious about feature flagging. It sounds great as on a small scale, but if you're doing that on a large scale, the permutations that you'd have to test become inexhaustible. And so your testing complexity and testing runtime become a real constraint that you have to deal with. The practice in and of itself is, I guess, a personal choice, but that would be my one caution there. But from a regulation point of view, provided you've taken the approach that we mentioned earlier about bringing the regulators or the auditors on board with the process, and you've invested that time automating your regulatory requirements as in the same way as you might have dealt with, I hate the word, but functional requirements, then I see no reason why you wouldn't be able to demonstrate compliance on a regular basis. The last thing I'd throw in there is regulation applies all the time, but in the old world, we're in a position where you typically would have a regulatory style audit on a regular basis, say every 3 months, 6 months, 12 months. The only reason that's really the case is it's just not feasible to do so more regularly. We're in a position where we can do that every release. So to me, we're actually in a much, much stronger position to be able to take advantage of those tools safely than you ever could in the case where you're only auditing once every 6 months.
I think all of that's exactly right. I agree with that completely. A couple of things to add is I think it takes a little bit of a mindset switch, a flip to really buy into this and understand it. But once you've made that switch, it seems to me obvious that making smaller, simpler changes is safer than making bigger, more complicated changes. And so if regulation is largely about trying to make sure that we don't hurt people in one way or another with our software, then they should be in favor of smaller, simpler changes. In order to be able to make smaller, simpler changes, that starts to get you into some complicated territory. So when you start thinking about isolating change from one another, you know, we get into trouble, and maybe ideas like feature branching and long-lived branches tend to trip us up. And so continuous integration is the tool that most effectively allows us to make smaller, simpler changes. If if we kind of follow that line of reasoning, then what that means is that the regulators should prefer, you know, trunk-based development, because that's the safe, you know, and continuous integration, because that's the safest thing. And as soon as you buy into that, then you've got to allow for ideas like branch by abstraction, dark launching, and feature toggles. I agree with Stuart 100% about feature toggles. Working in high consequence systems, I am very wary of the use of feature toggles. They are a very powerful tool, they're very useful, and sometimes you have to use them. But I would be very, very cautious about the number of feature toggles that I would allow into a medical system or a high performance finance system or something like that simultaneously. You know, if you've got one feature toggle, you can test both sides of the feature toggle before you release it. If you've got 50, you probably can't test all of those combinations in any reasonable amount of time or reasonable amount of, you know, server capacity. So you've got to take this stuff seriously. I said kind of in passing earlier on that I think that software is deeply, in some ways, deeply complex. This is the kind of thing that I mean. Information is deeply slippery stuff. And when we talk about things like branching and all those sorts of things, what we're really talking about is kind of concurrent information systems. We're talking about how you deal with information in different places and how you bring that information back together. And if anybody's done any concurrent programming of any kind, you know that that's the kind of thing that the world's top experts say, try not to do it because it's hard. It will trip you up. This is, you know, up there almost with quantum physics in terms of difficulty. And so we shouldn't be surprised that we have to, you know, agonize a little bit about it and make compromises. Continuous integration is not perfect. It's the best that we know how to do so far. But the compromise that we have with continuous integration is that if we want to work with continuous integration, it means that we must accept the requirement for us to make changes, to separate deployment and release. We must be comfortable with making changes to production without being ready to release a feature that takes multiple changes. And therefore the regulation has to keep up with that if it wants small, safer changes.
Great, thanks Dave, thanks Stuart. Okay, it's almost 7 o'clock, so we should draw this to a close. And thank you to everyone that's participated. Thank you for everyone's questions, for people that have just listened as well and absorbed the information. We hope you've found it a really useful session learning more about continuous delivery. Special thanks to our panelists, to Dave, to Ben, to Stuart and Lisa. Next week, we're going to be starting a new summer series of talks. It's going to cover quite a diverse range of topics. And our first speaker is going to be Andy Gray, who's a co-founder of BlockRocket. We'll be talking about all things blockchain. So thank you again for coming along tonight. And this talk has been recorded. So if you'd like to see it again or share it with other people, it'll be posted on the website shortly. Okay, many thanks. Have a good evening.